Welcome to this session. This session, we are going to discuss about rationalization of surds. Surds are expressions of this. These are examples of surds: root 2, root 3, root 5, cube root of 11, cube root of 15, etc. So our interest in this session is to carry out what we call rationalization. Now, rationalization means to change an expression from being a surd into just a rational number, or simply a number without a square root sign. So work out so examples. Rationalize. The denominator in, so the first one, 1 over root 2, b, 1 over root 5, and then c, 1 over root 7. So these actually are just the appetizers. So if you are given only one root term in the denominator, so what you do, you multiply that same surd both in the numerator and denominator, and then simplify. So a, 1 over root 2, so you multiply both the numerator by root 2 and denominator by root 2. So we'll have 1 times root 2 is root 2. Root 2 times root 2, remember, square root of a times square root of b, we just write one square root sign and multiply the numbers inside the root sign. So root 2 times root 2, just write the root sign and then 2 by 2, which is the same as square root of 2. 2 by 2 is 4. And when you're solving this one, we are only interested in the positive square root. So positive square root of 4 is 2. So write. So this will be the answer to that expression. B, 1 over root 5, you multiply by root 5 in the numerator and also denominator by root 5. So this will be 1 by root 5 is root 5. And then you write square root sign, 5 times 5. That's what you write. And then this root 5 by 5 is 25. And this, we are interested in only the positive square root. So you write root 5, square root of 25, you write 5. So this will be the solution. So this was A, B, C, 1 over root 7. So you multiply by root 7 over root 7, which would be 1 by root 7 is root 7. And then you write square root sign, 7 times 7. And then this will be root 7 divided by 7 times 7 is 49. So which will be root 7 divided by root 49 is 7. Remember, we are only interested in the positive square root, so don't write plus or minus 7. In this case, this becomes the solution. So sometimes you can also be asked to rationalize the numerator, not just the numerator alone. So rationalization. So this is another example. Rationalize the numerator in, so let's say a is root 3 over 4, B, root 2 over 5, and C, 3 root 2 over 7. Here, you solve them this way. So you write root 3 over 4. So you multiply both the numerator by root 3, denominator by root 3. So root 3 by root 3, you write one root sign, and then you multiply the numbers inside the square root sign. 4 times root 3 is just 4, and then you write root 3. So 3 by 3 is 9, divided by 4 root 3. Square root of 9 is 3. Therefore, we have 4 root 3. So this is the answer. Remember, when we say rationalize the numerator, means that now your new answer, the numerator should not have a surd expression. Next one, root 2 over 5. You multiply by root 2, you multiply by root 2. So which will be root 2 times root 2, you write 2 times 2, then root sign. 5 times root 2, you just write 5, and then root 2. So square root of this 2 by 2 is square root of 4 over 5 root 2. Square root of 4, the positive square root is 2, and then over 5 root 2. So this is the required answer. The numerator should not have a surd. That's the interpretation of rationalizing the numerator. Now 3 root 2 over 7, C. You multiply the root, remember this is 3 root 2, not a cube root of 2. So you multiply by root 2, that's the surd, over root 2, which will be, you write 3 square root sign, then 2 by 2. 7 times root 2 is 7 root 2, equals to 3 times square root of 4 over 7 root 2. And square root of 4 is 2. So it's like we have 3 times 2 over 7 root 2, which will be 3 by 2 is 6 over 7 root 2. So this will be the solution to that. And then, so next question, next example. So example 3, rationalize the denominator in, so the first question is 7 over 5 plus root 3. Now, when we have a surd, we have a sum of two numbers, maybe one which is a surd, another one is not a surd, or all of them are surds. To rationalize, you have to remember what we call the conjugate. So conjugate of A plus root B is simply you write A, and then this sign changes to minus, and vice versa. If you are given root A plus root B, then the conjugate becomes root A minus root B. So simply means that the sign in between changes to from minus to plus and vice versa. So for this one, you write 7 solution over 5 plus root 3, then multiply the numerator by 5 plus root 3, denominator by 5 plus root 3. Then with that multiplication, so not this should be minus, the conjugate. When this is plus, then the sign here must be minus. So minus, minus. So we'll have 7 into 5 minus root 3 over 5 plus root 3, and then 5 minus root 3. So 7 by 5 is 35. 7 by minus 3 is minus root 3 is minus 7 root 3. 5 by 5 is 25. 5 by minus root 3 is minus 5 root 3. Root 3 by 5 is positive 5 root 3. Plus minus is minus, and then square root of 3 by 3 is 9. So you write 35 minus 7 root 3 over 25. You see this one. This and this cancels out because they are the same values with opposite signs. Minus root 9 is 3. So we'll have 35 minus 7 root 3 divided by 25 minus 3 is 22. So which we can write it as 35 over 22 minus 7 over 22, then root 3. So that is what we write. Or you can write it as 7 over 22 into 7 into 35 is 5, and then minus root 3. So that is how you can write. Or you can even put it in a different form, say 7, 5 minus root 3 over 22. So all these are acceptable. And then example 2, 15 over square root of 10 minus square root of 10, square root of 5. So multiply by conjugate. So we have 15 over square root of 10 minus square root of 5 times square root of 10 plus square root of 5 divided by square root of 10 plus square root of 5. So the conjugate just simply changes this sign to plus when it was, if this is minus. So which will give us 15 into root 10 plus root 5 divided by root 10 minus root 5 into root 10 plus root 5. So this by this will give us 15 root 10 plus 15 root 5. Root 10 times root 10 is root 100. Root 10 times root 5 is root 50. Minus root 5 times root 10. Minus plus is minus. So 5 by 10 is 50. Minus plus is minus. Root 5 times root 5 is 25. Which will be 15 root 10 minus 15 root 5 divided by root 100 is 10. This and this cancels out. And then minus 5. Square root of 25 is 5. So this will be 15 root 10 minus 15 root 5. 10 minus 5 is 5. And we can say this is 5 over 5 root 10 minus 15 over 5 root 5. This will be 3 root 10 minus 3 root 5. Or we can write it as 3 into root 10 minus root 5. So this plus not minus. So all these signs are positive. So sorry for that. All these are positive from the first numerator. So this plus. And then next example, we have 9 over square root of 6 minus 2 root 2. So this is C. So solution, you write 9 divide by root 6 minus 2 root 2. Conjugate of this one will be root 6 plus 2 root 2 root 6 plus 2 root 2. So we'll have 9 into root 6 plus 2 root 2 divided by root 6 minus 2 root 2 into root 6 plus 2 root 2. And then 9 by root 6 is 9 root 6 plus 9 by 2 is 18 root 2. Root 6 times root 6 is root 36. Root 6 times 2 root 2, you write 2, and then you multiply those numbers inside the square root sign. So 2 by 6 is 12. Minus plus is minus. So you write this number 2, and you multiply 2 by 6. Minus plus is minus. 2 by 2 is 4. These numbers outside the square root, you multiply them, and then you write square root sign and multiply the numbers in the square root sign. So 2 by 2 is 4. Our next step, we'll have 9 root 6 plus 18 root 2 divided by square root of 36 is 6. This and this cancels out, minus square root of 4 is 2. 2 times 4 is 8. So which will be 9 root 6 plus 18 root 2 divided by minus 2. So you can write this one as 9 into root 6 plus 2 root 2 divided by minus 2. So that is how we solve that. And then another problem, if we have D, rationalize the denominator for root x plus root y divided by root x minus root y. So solution for this, you write root x plus root y over root x minus root y. And then the conjugate, because we are rationalizing the denominator, the conjugate of the denominator, now we change this to plus. So root x plus root y. So that we have now root x plus root y into root x plus root y over root x minus root y into root x plus root y. And then you start the normal multiplication. So root x times root x, yes, root x times x is x squared, plus root x times root y is root xy, plus root y times root x is root xy, root y times root y is plus square root of y squared, and then root x times root x is square root of x squared, root x times this one is plus root xy. Now this minus this plus will have minus, root y times root x is root xy, minus plus is minus, root y times root y is square root of y squared. So that is next step. And then next, square root of x squared, square and square root sign cancel. So we have x plus this and this are like terms, so maybe two of them, 2 root xy, and then plus square root of y squared is y, square root of x squared is x, and then this and this cancels out, square root of y squared is y. So therefore, the solution will be x plus 2 root xy plus y divided by x minus y. So this is the solution. So that is how we rationalize the numerator and denominator for a given surd expression. Thank you.